Hello all. We're going to solve in this video the first problem in the homework page 135. You can see that the block M weighs 2,500 grams resting on a frictionless inclined plane. We should always convert the mass into kilograms, and the plane, when it's frictionless, this means that it has no frictionless. It has no friction. It's a smooth surface. Inclined plane means it's an oblique plane. Main. It's joined by a string حبل. دايما لما نشوف string we say that there is the force called tension. And when we see a support طاولة أو أرض, we say that there is a normal force. Okay, we'll get into that in the coming question. First, find the magnitude of the weight. Okay, as you can see here, we always draw the forces on the figure. Okay, as you can see, the normal, tension, and weight. We have the mass equals 2,500 grams. We divide by 1,000 to convert into kilograms, which is 2.5. To calculate the magnitude of the weight, we say that weight equal mass times gravity, 2.5 times 10, which is 25 newtons. List and classify the forces acting on M. The forces are the weight. We say that the weight W, this is like the legend of the figure, tension T vector, and the normal N vector. Okay, the classification, tension and normal are contact forces, while the weight is a force acting from distance. Part C, write the condition of equilibrium of M. The condition of equilibrium includes all the forces, tension, weight, and normal, which are equals to zero vector. This is the condition of equilibrium. Okay, this is the vector relation. We cannot continue after this step, since the forces, as you can see here, don't have the same line of action. The tension is oblique, normal is oblique in the other direction, and the weight is downward. So we cannot continue to the next step, as we always between the tension and weight, we say that tension vector equals to minus weight vector. No, we cannot say that here. So we just stop in this step. Part D gives the characteristics of the forces. I'll just draw the table between the three forces, the tension, weight, and the normal vector. Okay, the four characteristics are the point of application. I just abbreviated the point of application. You should not do that in the exam. Line of action, direction, and magnitude. The tension, the point of application is A, the point of contact A. Line of action is oblique, and the direction is upwards, right. And the magnitude, we cannot calculate the magnitude here. Weight is the point of application. It's the center of mass or the center of gravity of M. Its direction is vertical and line of action vertical and direction downwards. Its magnitude is calculated 25 newtons. Point M, force M. The point of application is the point of contact between the M and the surface. M, the block and the surface. Line of action is oblique, as you can see, and direction upwards left. We cannot calculate also the magnitude of M. Part E, represent without scale the forces. I represented them on the figure. Part F, list and represent without scaling the forces of interaction between the block and the string. Okay, now here between the block and the string, this is different than the forces acting on M. This is the force of interaction. Forces of interaction, this is according to the principle of interaction. When an object A exerts a force on block B, on object B called Fa over B, block B will represent a reaction force on A called Fb over A. This is for memorizing, as I said before. The two forces acting on the block are the F, the force exerted by M on the string, and the string on M, as you can see here in the video. F on M, string on M, it's pulling it towards it, and the block is pulling the string downwards to the left. Fm over S means that the block M is pulling the string in this direction, and the string is pulling the block in this direction. These are the forces of interaction. Of course, this force is equivalent to the tension force, but we don't need to get into that. The second part, the 2i, the block M and the inclined plane. The forces of interaction between the block and the plane are called Fm over P and Ft over M. Okay, so the force exerted by M on P and plane يعني will be on M. This is the force exerted by the plane on M. Okay, since the plane is pushing the block upwards, the plane is pushing and holding the block upwards, while the block is making a force, downward force on the plane. It's called Fm, the block M on P. Okay, they should have the same line of action. مايلين شوي معي بالغلط. It's okay. So Fm over P. Okay, they have the same line, of course. Part G, if the spring were cut. Okay. Oh no, first I will name the forces Fm over F, the force exerted by the mass M on the surface. Fs over M is the force exerted by the surface on M, the block M. This is the second part. P over M is the force exerted by the P plane on M, on the mass, while the Fm over P, the force exerted by the mass on P, on the plane. Okay. Part G, if the spring were cut, the block M slides down. Explain why. Since there is no frictional forces that prevents the block from sliding, so since the surface is frictionless and the weight is pulling the block downwards. Okay, this is number one. Have a nice day. Thank you.